What's up guys, in this video we are going to learn about vector class that implements the list interface just like array list we have seen in the previous video. So in Java, both array list and vector implements the list interface. This means that both provides the same functionality. The difference between the vector class and the array list is the vector class actually synchronizes each individual operation. So what are these operations? Like these operations can be like the adding or removing, add all, everything, right? Or even getting. So these operations are actually synchronized. This means that whenever we want to perform some operation on vectors, the vector class automatically applies a lock to that operation, and hence for this very specific reason, vectors are less efficient as compared to the array list, right? So in array list, basically the operations are not synchronized. It is recommended to use array list instead of vector when you want to have a better performance. So if you could see my screen, I have refactored this project a little because if you see in the previous video, I had here as an array list, but instead of that, I renamed this to a list because we are dealing with the list interface. And inside that, I have created an array list demo. So in the same fashion, I'm going to again create a new class which I'm going to name as vector demo, right? And again, I'm going to have PSVM. This is a short form for main method. If you are using the IntelliJ, then this is PSVM is the short form for writing the main method. So I have a main method. So let's start with how do you define a vector in Java. So I'm going to have a vector of, you know, let's say of integer, and I'm going to have, let's say I'm going to type it as numbers is equals to new of vector, right? So I have created a vector instance here, and if you go inside this vector class, this actually extends an abstract list, which is basically an abstract class, but in the end it implements the list interface. And if you notice here inside this, right, every operation is basically synchronized, right? The copy into operation, the trim size operation, every operation inside the vector class is actually synchronized. So let's go back to, even the size, right? If you want to call the size method, this is actually synchronized. So synchronized basically, in Java provides a lock. Let's say, for example, there are two threads which is accessing this method, right? The size method. So what will happen is the first thread will, run the code, and as soon as that code is run, then and only then the second thread will, execute that method. So the second thread is actually waiting for the first thread to complete the operation, and once that is complete, then the second thread will do that operation and get the result back. But that's not the case with, the array list. As well as if you are, writing some data or reading some data, and if you are using two threads, then you will run into an exception called as a concurrent modification exception. So that's for this very specific reason, vectors are less efficient. So once we have seen the internal nitty-gritty here, we can actually start, adding the data inside this vector class. So just like array list, you can have a add method, and let's say I'm going to add 12 here. In the similar way, I can have, let's say 14. I can add some random numbers here, let's say 10, right? So I'm adding only three methods. So what I'm going to do is I'm going to have an s out, and in the same way I can call, the size method. So I'm going to run this code, and once I run this code, you'll see the output. The size is 3 because I have only added 3 elements. So just like array list, you can do the various operations. So let's see what are the various operations here. So I'm going to have s out and numbers dot, let's say I want to, get the value of specific index, let's say at the index 2. So index 2 will be the last element, which is value 10, right? So also if you want to, let's say, is there a set? Yes, there is a set method. So set method will, let's say at index 1, I want to change the value to from 14 to, let's say, 16. you can do that. Also, you can, do an add method at, let's say, index 0. I want to change the value from 12 to, let's say, I want to change it to 20. You can do that using add method as well. I think there's an error here. What's this error? This is actually adding. Okay, this is actually returning, you know, a null value. That's why it was giving me an error. So I'm going to remove this bracket. You cannot have a null system without the print line, a void, right? So as it was returning void, so there was nothing to print out. That's why I was having an error. So what this method will do is this is actually adding the value at 0th index of 20. If it's already present, it will update. If it's not present, it will, add that. So a set method, if you go inside this set method, so let's go inside this set method. This is also synchronized. It replaces the element at the specified position in this vector with the specified element, right? So this is basically replaces the element at specified index. So let's say that I want to add the value at, let's say, 3, and rather let's keep it as 0. And if I want to add the value at 3, let's see what happens. So when I run this code, right? So let's run this code, and you will see the output as index out of bound, because the set method is only applied if you if the index is within the size, right, within the size limit. But that's not the case with add method. You can have the third element here, so I'm going to keep it as 0. So I'm actually, when I use the add method, even if it goes above the index, it will, call the ensure capacity. If the vector is full, it will, resize it. But in our case, the default size is 10, so we are fine. So add will actually add at the third index with a value of 20, and if that value is already present, it will just update it, right? So it's always good to use this method if you want to, add at a specific index, right? Also, you can use an iterator here, just like array list. So what I'm going to do is iterator of, let's say, integer. Uh, Iterator of integer. I'm going to have an iterator, and then numbers dot iterator, right? So I'm going to use while loop while iterator dot has next. I'm going to have system dot print line iterator dot next. So this is going to print all the values inside this vectors collection. So I'm going to run this method, and you will see the output as, all this, right? So why is this coming as, okay, so I'm actually printing this 3. I got confused. So this is actually printing this 3 value first, and after adding the third element, which is 20, so we have the third element as 20. So I'm going to format this. Instead of this, I'm going to have an iterator to have a differentiator, right? Because this is confusing. So I'm going to run this code here. So if you see that iterator first value is 16, right? So I'm actually setting the value to be 16. So here I'm actually changing the value to be 16 at the 0th index. That's why I have inside an iterator I have an updated value. And then I have 14, and then I have 10, and then I have added the third element, which is 20. So this is quite similar to array list, but just that every operation inside vector is synchronized. That's why it has a performance overhead. So the recommended data structure when you want to deal with list is always use an array list. So I'll catch you up in the next tutorial. The next tutorial will be about linked list. And till then, goodbye and see you.